welcome to the Science Check Vocational Series on Chemistry. In this video, we will be learning about the extraction of iron, its reactions and processes. At the end of this lesson, you should be able to state the raw materials used in the extraction of iron, describe the reactions that occur at different stages of the process, describe how impurities are removed from the impure iron ore, state the composition of the waste gas given off during the process, and finally state the importance of slag. Have you ever wondered how the iron used for making your gates or burglar proofs is obtained? Iron is the 26th element on the periodic table and the 6th member of the first transition series. Due to its moderate reactivity, it is extracted from its ore by chemical reduction. The raw materials used in the extraction of iron are iron ore, coke, limestone, and blast of air. The commonly used ore is hematite, which contains iron 3 oxide. It is always used because of its high iron content. The coke serves a dual purpose of acting as a source of fuel and reducing agent. The blast of hot air is used for the combustion of the coke. The limestone is used for removing the impurities. The blast furnace, where the extraction takes place, is made up of steel lined with heat-resistant substances such as bricks because of the high temperature involved in the extraction process. As seen in the diagram, the iron ore, coke and limestone, collectively known as the charge, are fed into the furnace from the top, while the blast of hot air is pumped into the furnace from the bottom through tubes known as tires, spelled tuyeres. Inside the furnace, the following reactions occur at different stages of the furnace. At the bottom, the coke combines with the blast of hot air to form carbon 4 oxide, which rises to the middle of the furnace. This reaction is an exothermic process, and the heat generated is used to heat up the furnace throughout the extraction process. That high temperature of about 1800 degrees Celsius is used to bring about the thermal decomposition of limestone into quicklime and carbon 4 oxide. At the middle of the furnace, the volume of hydrogen is greatly reduced, so the carbon 4 oxide produced at the bottom rises and combines with the excess coke at the middle of the furnace and is reduced to carbon 2 oxide. Being an endothermic process, it reduces the temperature to about 800 degrees Celsius at the middle of the furnace to create an optimal temperature for the actual reduction of iron 3 oxide at the top of the furnace. Meanwhile, the quicklime produced at the bottom from the decomposition of the limestone combines with the silica impurities in neutralization reaction and removes them as slag, that is calcium triosilicate 4, or what you call calcium trisilicate. Then at the top of the furnace, the reduction of iron takes place at about 400 degrees Celsius. The carbon 2 oxide produced at the middle of the furnace rises to the top of the furnace and reduces the iron 3 oxide to a metallic iron, which sinks to the bottom of the furnace. Being less dense than iron, the slag flows on top of the molten iron and prevents it from oxidation by atmospheric oxygen, as shown in the diagram. The iron is tapped off through the hole and taken for further purification. In actual sense, the iron obtained at this stage is known as pig iron. It is the most impure form of iron and is of little or no value because of its high carbon content, which makes it very hard and brittle. hence the need for purification. The slag is tapped off and used for the resurfacing of roads. The waste gas is made up of the unreacted nitrogen from the blast of hot air, the carbon 4 oxide produced at the final stage, and the unreacted carbon 2 oxide are released into the atmosphere through pipes as shown in the diagram. Note that of the 5 reactions, equation 1, 3, and 5 are redox reactions. Equation 4 is a neutralization reaction between an acidic oxide and a basic oxide, while equation 2 is a thermal decomposition. That's all on the extraction of iron. So, if you enjoyed this lesson, like this video, follow us on our social media platforms, and subscribe to our YouTube channel for more interesting educational videos. Thank you for watching.